My boys, we have a wonderful machine in our possession, having until we fully explore the full potential of this miraculous machine. We shall tell no one. Welcome to the wonderful world of random sequencing. Today we're going to be showing you a lot of things, but we're going to start off with showing you how to do random sequencing mathematics. And the way it goes is, I'll give you an example right here. We're going to add the sevens here. So the way you add the sevens is, this is 3 sevens. That's 7, 7, 7. So that's 3 sevens. Here's 1 7. So that's 4 sevens. How do you say 4 sevens? 4, 7. Now, how do you add all these? There's 3 7 plus 4 7. That's 7 7. 8 7. 9 7. So how do you say 9 7? 9 7. Here's another example. Here's 27 plus 27. That's equal to 4 sevens. That's also equal to 54. 2 2, 54. So that's how you add using random sequencing math. Also, you could do it with the 38. In other words, this is the 38. That is equal to 18 plus 28. Now 28 carries the statement 2 8, which is 8 8. So add one more 8. That makes 3 8. So there's your 38. So the way, so in a way, you could already determine what this 18 is going to be linked with. It's going to be linked with a 28, or it's going to be linked with a 28 like this, or a 2 8, or a 28. So, so it's just an addition way of, it's a form of adding. Let me show you how to why the 14 is equal to 27. Now, here's the 27. The 27 carries a statement 2 sevens. And 7 plus 7 is equal to 14. So if you have a 14 here, you're going to probably get a 27 because they're equal to each other. I'd like to talk about this sequence right here. We have the 36 sequence to a 36. Now, 36 plus 36 is equal to 72. The way that gets answered is by a reverse sequence of what 27 is. If you reverse that sequence, that makes 72. So whenever you see a 27 linked to a 36, that 27 represents 72. Another thing is that you see that 33 right there? That 33 is a metamorph. That's a anatomical sequence. It's an anatomical 8. In other words, if you were to split an 8 in half, you would get 3 3. So that's why that 33 sequences to an 8. I like to talk about also the 18. The 18 is equal to 29. And the reason why is because the 29 carries a statement 2 9s, and that is 9 9. And 9 plus 9 is equal to 18. So as you can see right here, we have the 29, and then it's sequenced to an 8, and then it's sequenced to a 1, that's 18. So also 18 plus 18 is equal to 36. I'd like to talk about the functionality of the 29. The 29 also carries the add statement, the add 2 as in 2 cells. Notice that above there you have the 25. It created a 20, or the 20 was created, and then after that a 5. The reason why it created a 20 and a 5 is because it's equal to these two, the 25 right here. Now, the statement continues right here, add 2 cells, and so what you have right here is the 25 plus 25, and that is equals, the 1 1 on the left hand side is the equal statement. Equals what? 50, which is 50. Another thing is over here is that if you look at the 36 30 sequence, on the left hand side are the statements. Like here's your statements right here on the left hand side. Your value numbers are on the right hand side. So the value number is 60. So if you have a 30, all you have to do is put another 30 there, and now you have 30 30. That's the add statement, add 2 cells. 30 30 equals 60 right there. I'd like to talk about the 14 again over here. So we have the 14 sequence to 2 7 because 27 carries a statement 2 7s, which is 7 7. 7 plus 7 is equal to 14. So 2 7s is 7 7, and 7 plus 7 is equal to 14. So after that it's sequenced to a 1. So if it's sequenced to a 1, it'll probably sequence to a 4. So which it did right here. And it continues on and on. And what we have right here, we also have 14. And the reason why it did that is because when it created the 32 is linked to the 17. On the left-hand side, we have the statements. And the value numbers are on the right-hand side. So the value of numbers is 27. So the left-hand side has the statement I am. That is your I am statement linked to a 27. And then it's sequenced to this 14. And now after that, it is sequenced to another 14 to create 28. Now the reason why that is because 14 plus 14 is equal to 28. I'd like to talk about how the 23 played two different roles here. One is that it adds the 23 plus 23 and uses this statement equals in. This is the equals ins or the equals. That's the 3 in binary notation is 1 1, which is the equal statement. Equals what? 46. So 23 plus 23 is 46. But then it also used this the 10, which is a binary notation digit, meaning 2. 2 linked to a 3 makes 23. So what you have right here is 23 plus 23 plus 23 is equal to 69. I'd like to talk about the interesting sequence here, how the 3, which is the equal statement, in binary notation, the 3 is 1 1, which is the equal statement, equals 4 4, and then this 13 is the I am statement. I am what? 8. So equals 4 4, I am 8. I'd like to talk about the concept number 35, which is equal to 5 5 5, and 5 plus 5 plus 5 is equal to 15. So 15 is equal to 35 and 35 is equal to 15. That's using random sequence math. Okay, as you can see right here, we do have a 15. And what happens is it formed a I-form point. This is the form point statement. And that equals 35. So the 15 is equal to 35 right here. And it did it over here again, but this time it created a different statement. It's a form sequence. This is the form sequence statement and a sequence to a 15. And as you can see over here also, with the 29 carries the add 2, it's the add statement of 2 cells. In other words, we got the 15 plus another 15, that is equal to 30. I'd like to show you how to read between the lines on these sequences. Like whenever you see like 2 digits, like right here, we have 2 cells, 17, 23. Now on the left hand side, we have the statements. On the right hand side, you have the value number. So on the left hand side, we have the 1 2. That is the R statement. That's A-R-A as an R. And what is it? 37. So this tells you that your environment is 37. So R37. So what it created a 37 on the next sequence, and it followed with the 7 over here. So now you know, I mean, if you assume that, you want to play a 37 and probably a 7 because that's the environment you're in. And after that it's going to create a 3. And then after that it's going to create a 7. So it's basically the environment you're in. So again, if you see a 1723, that describes a 37 environment. So then you know that you should probably create a 37 and a 7, followed by a 3 and a 7. I'd like to talk about the number 31 here. And the 31 carries a statement 3 ones, which is 111, and 111 is equal to 7 in binary notation. So as you can see right here, we have the 31 followed, and up above we have the I am statement. So, and it's followed by a 7. So 7 I am 31. 7 I am 31. I'd like to show you how the 2220 created a 60 here. And the reason why it did that is because here we have the add statement over here. The 9 is the add statement. So it adds 20 plus 20 plus 20 is equals the 1 1 right there. Is that the equal statement? Equals what? 60, which is 60. I'd like to talk about this sequence right here, the 23 sequence to 33. The reason why it does that is because the 23 carries the statement 2 3s. And what is 2 3s? 3 3s. And it did it over here again too. 33 is equal to 23s. And when it another thing that If you were to add up the 23 and 33, add the 3's, 3 plus 3 plus 3 plus, and link it to a 2, that makes a 29. So over here we have a 29, and this forms 29, and this over here also forms 29. So we got 3 29s, and 3 29s, 3 times 29 is 87. Notice this sequence, the 23-23 sequence, that makes 4 3's. So right here we have the I form statement linked to a 33, and when it does that, it creates a statement saying the I am 43. I am 43. So 2 3's plus 2 3's is 4 3's. Another thing I'd like to show you is the this statement right here. You see how you have the 19? Well, the 13 linked to a 33 makes a 19. And the way it does that is 3 plus 3 plus 3 linked to a 1 makes 19. So this statement says IC, the 18 is the IC statement, 19, and it forms the 13 and a 33 to make 19 right there. I'd like to talk about this sequence right here. And what we have here is the add statement. The 9 is the add statement. And what you have is 11, 12. What that forms is 27. And the way it does that is because you have the 1, 1, 1. The 1, 1, 1 in binary notation is 7. And it links to a 2, so it makes 27. And 27 is equal to 7, 7, which is equal to 14. 7 plus 7 is equal to 14. So the 14 is equal to 27, and 27 is equal to 14. So we have add 27, and then this is the I am statement. I am what? 14. Another thing is that the over here we have the 11. Now the 21 carries the statement 2 1s. What is 2 1s? 1 1. So the 21 is equal to 11, and 11 is equal to 21. That's pretty much it. I covered a lot of material here, and I hope you enjoyed the sequences. And we'll see you in the next wonderful world of random sequencing. And folks, as always, please click the subscribe button below, show some love, give me some thumbs up. I have links below with PayPal and Patreon. And I will see you on the next wonderful world of random sequencing.